Okay, so now let's take a look at insertion. Okay, when we are insert an item into a linked list, what kind of different scenario or different case can happen? Okay. Okay, you think about that, right? You have a line of students, okay, line up, and there will be new student coming, okay? He wanted to join the line. How many different scenarios can be? He can join at the beginning of the line, okay? He can join in the middle of the line. He can join to the end of the line. That's a 3 different cases, okay, when we do the adding new value to the list. So here, let's take a look at what's the different code we need to handle, right? When we insert a node into a linked list, because we don't know, right? We don't know. So here in my linked list class, I create a function called add first. Okay, so which means, hey, you can call me this function to insert a new node at the beginning of the list. Okay. Besides the self parameter, we have a second parameter called a node. The node is just a new node you want to insert. Okay. So now node.next equals to self.head. Self.head equals to node. Think about that, right? You already have a list. Okay, you have the head is pointing to the first node. Now you wanted to insert a new node, make this new node to be the head. What are you supposed to do? Julian, this is the code. Just 2 lines of code. Okay, you explain to me what is actually he's doing.
These 2 lines of code are for establishing nodes inside the class or the function.
I know what is actually doing. Explain to me. 2 lines of code. What is doing? Can I understand it? What is this 2 lines of code doing? Julie, understand it?
It moves on to the next node.
Move on to the next node. What do we move on?
No,
to the next node?
it does like take in the first node.
Taking the first node. Okay, node.next equals to self.head. What is this doing here? Victor, what is this doing here? Node.x equals to self.head.
Oh, it means like the first one.
What the first one? It's the node.
It's moving on to the next one, which is like the first.
Okay, remember the node here is the new node you wanted to insert. It's a new node you wanted to make to be the new head. Okay, so now let's look at here. This is your existing list you have, right? We have a head. Head is pointing to the first node, and I may have extra nodes. Okay, so now if I wanted to add a new value or new node, right, called data 0, it's a node, new node I want to insert. Okay, passing the new node parameter, very good. Now, what I do, node.x equals to self.head, right? I know head is the node 1. So I make the new nodes dot x pointing to the current head node. Okay, this is line of code doing. And what's next? Next, you need to update the head to be the new node. That's it. 2 steps helping you replace or update your head to be the new node, right? Or you insert the new node at the beginning of the whole list. Louis, are you following?
Yeah.
Do you understand these 2 lines of code?
Yes.
Okay, I'm gonna ask you guys write the same code in today's assignment. Okay, so if you don't understand it, if you have any question, you're better asking right now. Okay, Jeffrey, did you get that? Jeffrey? Hello, Jeffrey, you there? Okay. So we just covered the first case, insert at the beginning. Okay. Now let's take a look at the, adding at the end firstly, because adding in the middle will be a little bit complicated. Right? Let's look at another simple case, right? Which is insert at the node. At the end, okay, sorry, at the end, okay? So this is actual code, okay? Aston, by looking at the code, okay, can you explain to us what here we are doing? What is code doing? I know this code is basically adding a new node, right, to the end of the list. But what is exactly this code meaning here? Aston? Aston, you there?
Yeah, I'm here.
Okay. First, take a look at the if condition. If not self.head, self.head equals to node and return. Return means what? I complete the function. So what is this if condition doing here?
Making the node the head of the list.
Making the new node to be head of the list. In what case? Because we said insert at the end of the list, right? Why making me at the head of the list? In what kind of like scenario we need to do that? Look at the if condition. What is the if condition doing here, Aston?
If it is not already the head.
Not already the head. If not self-head, it's basically check if the head is none or not. If the head is none, what does it mean? The list is empty. Possible? Right? It's possible. You insert a new node to the list, but the list is empty. Explaining. The if not self.head condition basically checking if my head is none. If it's not none, no, okay, it's a double negative, okay? If not none, right? Not, because none represent false, but I wanted to make the if we choose, it should be not none. Okay, so basically this if condition means this list is empty. Remember this, next time I ask you to check if the list is empty, you know, oh, if not head, right, self-head, right? If list is empty, then insert at the end, it's equals to become the new head. Am I right? Right? So self head equals to node. That's it. Return. I finish. Okay. Okay. If the head is not null, which means there's already node existing in the list, what am I supposed to do? Aston, I give you a list which is not empty. Now I said, hey, insert a new node at the end of the list. What are you supposed to do? Or you can also look at the code. Aston?
I'm not sure.
Okay. For current node in self, okay, pass, which means I looping the list, okay, I looping the list because I need what? I need insert at the end, right? And as I said, a list, you only know the head. You need to find the last node, which means you have to loop. Okay, loop on the last node. Okay, so here is basically telling me there could be a second case to loop the node, right? Okay, I wanted to test it on myself. 1 second, I think the list. Okay, I have this list, right? Okay, so this is a node class. This is a linked list class. Okay, and we said the print list, we're using while loop. Okay, let me see if I can do a for node in self and print node dot data. Okay. Oh, for node in self is the correct node in self. Node in self. Okay, I think something is different here. Anyway, let me complete that and I can test later. So here, go back to this code, okay? This code basically means looping, because pass means what? Pass means I don't do anything. I didn't do anything, okay? And when you wanted to iterate every node in the list, okay, you just need to do the for node in self and make sure you do the pass, because you iterate every node but without doing anything. Why we need to do that? Because we need to find the last node. Once this for loop completed, it means it's moved to the last node of the list. And then if we want to insert a new node to the end, which means what? Which means insert, make the next of the last node to be the new node. Am I right? Let's take a look at that. I have an existing node, like I have an existing list look like this. Okay. And I wanted to parse in the new node, insert it at the end of the list. This case is what? This case is if the node itself is empty, head is empty, right? So I just need to point head to the new node. That's it. Check if empty list. If so, just set head to the new node. Okay, that's easy to understand. Okay, in the case of the list is not empty, what I need to do is I need to in the for loop to find the last node, right? And make the next of the last node to be the new node. That's it. I didn't change the head because head is always be the first node. I just need to change the next of the last node pointing to the new node. Okay? So the last node is become the new node. That's it. Okay? You don't need to change anything to the last node because the next is pointing to none. It's pointing to none. Let's insert at the end. Okay? Now, you know what? So now, what I want to do is I wanted to implement it first, right? Def. Okay? You guys pay attention here, right? Because this is exactly I wanted you to do in the assignment. Okay? So do the insertion. Insert, right? What is the function that we use here? Add the last, add first, right? Add first. Okay, we said add first. Okay, self, comma, node. That's a parameter. That's a parameter. So when we say add first, okay, we know self dot add, right? Node dot next equals to self dot add. I make the next reference of the new node pointing to the current head, which is the first node. Okay, and then I need update head to the new node. That's it. That's it. Okay, let's try this. Okay, let's try this. I have the node create. I have the linked list create. I print out the list firstly. Okay, let's do that. Okay, okay, here. Why I have this symbol? Because I'm using what? Comma and this, right? Remember, what is the purpose of this? This is adding the extra character after every print out. Okay, that's the reason why every value, after every value, I add this. It's more like obvious, right? It looks like a list. Right now, I have a list of 1, 2, 3. Now, what I'm gonna do? My linked list dot add first. I wanted to add a new node called what? Node. We don't have 4, right? 4. What I'm doing? I create a new node 4, and I add it first to the list. Now, if I call the print list function again, what I gonna get? What I gonna get? Louis, watch where we print out this. Louis, tell me, what's the print of this?
Just 1 to 1 to 4.
1, 2, 4. That's your answer?
Yeah, 1, 2, 3, and 4. Yeah.
1, 2, 3, 4.
Yes.
Any different, Jeffrey? What's the print out here?
1 to 4.
1, 2, 4.
Yeah, because there's 4 nodes.
Now, where are the 3? 1, 2, 4. 1, 2, 3, 4.
I think so. Yeah.
Okay, Victor.
I think it's only 1, 2, and 3.
Why do you think it's only 1, 2, 3?
Wait, it's 1 all the way to 4 though.
1, 2, 3, 4.
Yes.
Judy,
Eh?
what's up right now?
Eh.
It's very difficult if you really follow me. I already have a list, right? I already have a list. Now I delete the last print, okay? I already have a list. My printout list is 1, 2, 3. Now what I do, add a new node at the beginning of my list, and I print out the list again. And I'm just asking you, what is the printout? Julian, what's the printout?
1, 2, 3, 4.
Aston?
1, 2, 3. Yeah, 1, 2, 3, 4.
Aston, what do you think?
4, 1, 2, 3.
4, 1, 2, 3, right? We just said it's an add first. What's mean at first? At the beginning, insert the new node at the beginning of the list. So it cannot be 1, 2, 3, 4, right? It's 4, 1, 2, 3. Okay, it's 4, 1, 2, 3, right? You know what? I need to print out a line break. It will be more clear to you guys. Louis,
Yes.
is it correct?
Yeah, I think so. I just forgot to read that.
Okay. Insert a new node at the beginning of at the beginning, right? Of course. It's 1, 2. Where is my first printout? Okay. 4, 1, 2, 3. Okay. Now add another function inside my linked list. Okay. Def add last self comma node. Okay. In this function we said, okay, look at here. What we first need to check. If not self head. Okay. Because I need to check if the current list is empty or not. Right? If it's empty, I don't need a looper to find the last node because there's no last node. Right? There's only a head. I just need to set my new node to the head. That's it. Right? So if not self.head. Okay. Jeffrey, what did this line of code mean?
If not self head, that means if the object is not the head, then it'll add a node at the last.
That's me if the object is not self-head, okay? I know that's a literal meaning, but what's the code meaning here?
It'll add the node if it's not the head.
Louis, what I'm doing here? What's meaning of if not self.head?
So if a thing is not the correct thing, is going to run something. I think if one is not in the first place, then
Okay. I'm doing here is checking if the list is empty. I said again, this condition is checking if the node or if the list is empty. Why I say that? Think about that. If the list is empty, the self.head equals what? None. Right? So if not none, double negative is true. So this condition is going to become true. That's the reason why I said if not self.head, what am I supposed to do? Julian, if the list is empty, what I'm supposed to do?
Add first node.
How do I add the new node? Be the first one. Oh. Julian?
Node 6.
Node 6. Self.head equals to the node. Okay? The list is empty. The head is also pointing to none. What do you need to do? I set the new node to be head. That's it. And my function done. Return. Okay? And what's next? If the list, you know what? Let me put some comments here. Okay? Check if list is empty. If so, set head to the new node. Clear. Okay? So then, if not empty, loop to find the last node. Why do I need to find the last node? Because I need to add to the end. That's the reason why it's called add last. We're using for current node in self. And we do pass. What's a pass mean? Pass means I do nothing. Why just looping, iterate every node in the list. And when the loop iterating completed, the current node is after the last node. And then I just need the current node dot next equals to node. That's it. Any question for this add last function? No question? Louis, Jeffrey? You're gonna write in the same in your assignment, okay? If you don't understand it, you need to tell me. Now let's take a look at. Okay, so now my list is what? My list is 2, 1, 2, 3, right? Insert the new node at the end. How do you insert? How to write in the code? Louis, how can I write this code? I wanted to insert a new node at the end. How can I write it here? Louis?
Yes.
How can I write in the code here? I want to insert a new node at the end.
Just put I just create a new thing like node 5 or something.
What? Writing. Tell me. Every letter I'm gonna write it.
I think it's node 5 space equals space node uppercase and node and then parentheses 5.
That's it.
Well, I said there was a node before that, like the one on line 37.
Slide 37. Okay, 37. Fine. You said like, oh, I can create a new node called node 5, and of the node class. Then what's next? I just create a node. I want to insert the node into the end.
Oh, wait. I I think you write it like 49, my link add, and then
Okay, good. My linked list is my list object. Dot what?
dot add underscore last
Last. Okay. What I should pass into it?
node parentheses 5.
Node parentheses 5 or node 5?
Oh yeah, node 5, yeah.
Yeah, you already create a variable called a node 5, right? Representing the
Node
node
5,
5,
yeah.
right? You just put that. Very good. Now I print. How could I print? Same thing. You call the print list function of the list object. Jeffrey, what's the print out of this line of code?
It will print out node 1 to 5.
Say it again.
It will print out node 1 to 5.
What's the first node?
The first node?
Yeah.
It is node 1
Why?
because
It's 4. Did you look at what's the current code?
Yeah, it says add first node 4.
Huh? Did you look at the current code? What is it? Link to the list object is not iterable. Okay? Look at here. First I create 1, 2, 3. Right?
Mm-hmm.
And then I insert a node at the beginning of the list. Right? It's already 4, 1, 2, 3. Right? And now I insert a new node 5 at the end, right? So it should be 4, 1, 2, 3, 5. 4, 1, 2, 3, 5. If you run that, right? Right now, let's give you this arrow. Okay, it said what? Let's look at the arrow. Type arrow, link the list object is not iterable. Linked list object is not iterable. Okay, so you know what? Let me take a look at the code here for current node in self. Okay, let's go to the reference. It's Google Python linked list, right? Python list. Okay, so that is just to teach you guys, right? If you are facing any problem of your code, how are you going to solve this? Insert a new node, okay? Insert at the end. This is using the same thing here. Okay, I need to take a look at how they define the list. Iterate. Okay, here, iterate. How to traverse a linked list. One of the most common things you will do with a linked list is to traverse it. Traversing means go through every single node, starting with the head of the linked list and the ending on the node that has the next value of num. Okay, traversing is just a fancy way to say iterating. So with that in mind, create an iterate to add the same behave to the linked list that you were expecting from a normal list. Okay. Oh, okay. I see what I'm talking about here. So we cannot using the for what we're doing here, right? We're using what? For current node in self directly. Okay, because it's saying if you want to using for, you have to create an iterate function first. That is make. It is eligible by using for loop. Remember what I'm talking about. Because the linked list is dynamic. Okay? You cannot using for directly because it don't know what's the ending point of the whole loop. And here he creating iter. Iter is a similar function, predefined function as init. Okay? If you're telling him what the logic of iterating, they still can using for loop. So what they're missing here is this function. So if I copy this function to here, okay, what is this function doing here is it's basically to the while loop, right? While loop. With that, then I can using for loop, okay, against the linked list. Now if we test it, do you see here 4, 1, 2, 3, 5? Okay, here it's a little bit complicated. Okay, why do I need to add this function? Right, it's a function called underscore iterate, because this function will be used, invoked when you are calling the for loop against this object. But you may ask me, hey, you're already explaining why, right? Can I use why instead of using for? Of course. What's my purpose here? My purpose here is wanting to find the last node. What is the find the last node, right? How about that, right? I don't do that. I just using here. How can I find the last node? Same logic. Okay? You can use while. Let's do that. Temp, okay, equals to self head. Create a temp, right? Create a temp variable, make it equals to self.head. Now I need to have a while. Remember, we need to have a condition. Okay? And then temp equals temp.next. Okay? So what should I put in the condition? Remember, I need to check. I need to find the last node. Okay? So the while loop should be stopped when we find the last node. So now the condition should be temp.next equals to none. Or you can write like that. While right like this. What's the difference here? This is only checking, right? Till the none. But here the difference is I need to find the last node. I need to find the last node, and when I find the last node, I stop. Because why? Because here I still need up to the next of my last node. Do you see the difference? The logic is very similar. Okay, the logic is very similar. Let me run that. I got the same, right? The logic is very similar. The only difference is the condition. Here I'm checking temp, which means the while loop will be stopped when the temp equals to none. But here, I cannot using this because I need holding the last node. Cannot let it pass. So that's the reason why I check if the temp.next equals none. If it is none, which means this is false, right? This is false, the while is stopped. So I got the last node reference. And then I said the last node.next equals to none. Are we clear? Aston, you understand this? I didn't hear you.
Yes.
Okay. Jeffrey, you
Yep.
understand this?
Sure.
Sure. You're gonna write it, okay? You're gonna write it.
In the assignment?
Yes.
Okay.
Victor, understand this?
Yup.
Okay. Now go back to my slides. Okay. Look at the animation, right? I just said, oh, we already go through that, right? Okay. Anyway, now talking about the last case, insert in the middle. We're just talking about the head, and that's a too simple way, a simple case. The third case is insert in the middle. Okay. Look at the code, right? It's a little bit complicated than the previous two cases. First of all, right, it has one more parameter called target node data. What does it mean? Because we said insert in the middle, which means I need to have a target position. That's the reason why I'm plotting target node data. Okay, look at here. This is my existing node. Fine. I want to add a new node called 2.5, right? After data 2. Data 2 is my target node, right? It's telling me, hey, what's the position or after whom you want to insert a new node. And 2.5, data 2.5 is my new node, right? It's my new node. Okay, now let's take a look at the code line by line. If not self.head, what does it mean? Louis, what does this line of code mean? Louis,
Yes.
what does this line of code mean?
It's like if it's not something, something's gonna happen.
What can happen?
It's gonna raise expectation. List is empty, so I think it's gonna print list is empty.
So then tell me, what's the condition of this? What's the meaning of this condition?
What do you mean?
What do I mean? I mean, what is this condition? What is meaning of this if condition? If not self.head.
So if the self dot head is not the self dot head, then it's the raise expectation is gonna happen.
Jeffrey,
Yep.
if not self.head, what does it mean?
If the node is actually not the first node in the list, then
Which node? We don't have a node here, right? I'm just checking. If not self.head, I just check head.
yeah, if not the first.
Julian, what does it mean? Julian?
I don't know.
Okay, Victor, what does it mean?
Wait, what mean?
I mean, this if condition, if not
So
self.head.
if it's not like the first node in the list, it will raise the exception list is empty.
Okay, I said it again, okay, guys. If not self.head, this condition is checking if the list is empty. Okay, that's the third time I explained that. Okay, this if condition is checking if the list is empty. Okay, so in this case, and after, we have a talking node data, right? So if the list is empty, it's an exception. What's the meaning of exception? You do something you are not expecting happening, so it's called exception. So whenever in the programming, if something is not normal happening, it's called exception. So here we raise exception. You can understand it's close to error, okay, but it's a checked error, okay. So in this case, if somebody asks you to insert the node to the target node data, but the given list is empty, I need to raise exception, okay. That's a exception checking. Second one, for node in self, if node.data equals to target node data, new node.next equals to node.next, node next equals to new node. Okay, I think you guys confusing, already confused, lost, right? Ashton, are you able to try to understand this line of code? What is it here doing? For node in self, we know it's looping every node in the list, okay? And we are checking if node.data equals to target node data. What does it mean?
The node already exists.
Okay, speak louder.
If the node already exists.
If the node already it's looking, it's finding the target node, because we said parsing the target node data, right? In this case, it's data 2. I need to find the node whose value is data 2. That's the if condition doing. Okay? So if this condition is true, which means I found it. I found this node. So what am I supposed to do next?
The next value of the
What is this? New node.next to the node.next. What does it mean? What is node.next? What is new node.next? Who is new node here?
New node is 2.5.
Okay. His next pointing to who?
3.
Okay. Pointing to data 3. Again, okay? For node in, we are looping every node in the list, checking if the node data equals to target node data. Okay? So basically, he's checking the first node, data 1. Hey, the data 1 equals to the, okay. First check if the first node is data 2. True or false? False. Then I go to the next node. I'm checking, hey, is the second node data equals to data 2? Hey, it's correct. It's true. So now, okay, here, I find the second node is the target node I'm looking for. So I make the new node.next equals to node.next. What's node here? Node is second node. The second node.next is third node. So I make the next of the new node to be the third node. Okay? And then what? I make the second node.next equals to new node. What's actually, look at the diagram. Okay? If not empty, find the target node first. And then what? Break the existing next reference from node 2 to node 3. Make the node 2 next to the new node. On the other hand, make the next of the new node to be the data 3. That's this 2 line of code doing. Okay? Repeat again. Node data equals to target node. Find the second node, right? The node is second node. And then new node.next equals to node.next, right? Because early the second node next is node 3. That's the reason why I make the node.next is node 3. I make the new node.next make node 3, and then I adjust the next of the second node to be the new node. Okay, it's just like a chain. You break the early link, right? And then you insert a new node into it, right? Make it pointing to the new node, and then make the next of the new node pointing to the early next node. Understand it? Louis, are you following? You clear? Julian,
Yes.
you understand it?
Yes.
Okay, very good. So now, look at the code, right? Raise exception node with data not found. Another possibility is the target node data that is not existing in the node. Okay, in this case, you need to raise exception also. Okay, so let's try and write the code together, right? Okay, so we said we have add first, add last. Now we need to add what? After. Okay, add after means what? Add after the target node, right? So def add after self target node data and then the new node. Okay, so now what are we supposed to do? Again, when you are writing more and more code, okay, exception checking is mandatory now, okay? Because you cannot have a leaking code in your program logic, okay? You have to think about the all different cases. The first case is if not, right? A self dot add, which means, oh, if the list is empty, then what's the point to find out input to the target node, right? So you should raise an exception directly. The list is empty. You know what? Let's test this case, okay? Let's test this case. So I do it here. I create here, line number 46. I create a new list. At that time, the list is empty. So if I said, hey, my list dot add after, I don't know, for something random, right? And it's empty. So no matter what target node data, it's empty. And node 0. Okay. If I run this code, let's take a look at, right? Because the exception gonna happen. This is true. The exception gonna raise it. Let's take a look at what happened here. Exception. List is empty. Right? That's called checked exception. Think about that, right? When you are doing any, for example, website. Okay, you log in. Username, password. Right? Not every time you put the correct username password. Right? He may put the incorrect one. So the system gonna do the checking and then raise an error or raise exception. Hey, sorry, inconsistent password, you know, and username. That's called a check the exception or check the error. Same thing here. Okay. So let's continue here, right? After I finish the checking, what I'm supposed to do, I need to find the target node. Okay, I can using for. I can using for just like the sample code here. But again, what I said, if you want to using for against the linked list, you have to, right? You have to add this function. Add this function. Okay. I don't want that. I want to using our old way, right? We said a temp. For target node, target equals to self.head. Again, I wanted to using the while loop to find the target node. So while, what's the condition here? The condition is I need a stop when I find the target node. So I should write if not target dot data equals 2. Double equals 2, okay? Double equals 2 is compare the value. Okay, single equals 2 is assign the value. That's a different. Target node data. Why I said node? Why I put not? Because I want the while is stop when we find it. If it's not equals 2, I just keep looping. You get my point? I keep looping. Target to target dot next. But after I found that, okay, after I found that, target after I found out what I should do, target dot next equal to the new node. Oh, wait a second, I should change that. Node dot next equals to target next firstly. And then, why do I say that? Node dot next, make the next of the new node to be the target node, target next, and then change the target next make to the node. Can I switch them? Change the target next first. Connor, are you there? Connor?
Yeah.
So this 2 line of code, can I switch them?
Node.next equals target not next. Target not next equals node.
Yeah. So can I make the target next equals to node first?
I don't think so, because when you're doing node.next equals target.next, you're changing what the next node is. Wait, let me. Node.next equals target.next. Target.next equals node.
Okay. The answer is no, right? You cannot adjust the order. Why? Suppose, okay, you are changing the target next first equals to the new node. Then what's the point to node next equals target next, right? Remember, target next is equals to node now, right? That's wrong, right? You're basically making the new node point to himself. Okay? That's the reason why you cannot adjust the order of these 2 lines. You have to make sure the new node next equals to the target next, because at that moment, target next is still pointing to the original next, right? Look at this diagram, right? New node next equals to node next, right? Node next is who? Node 3. Okay? It's node 3. And after you hold the node 3, then you can change. Oh, I can adjust. I can update the next of my node 2 to the new one. That's very important. I know it's confusing here, but you need to really understand it. Okay. So, and then that's it. I finished it. Right? I finished that. And I have another condition said what? Another condition is said raise condition. Okay, so I should put a return. And here, there's actually a leaking code here. Thinking about that, right? So let's test it firstly. Let's test it firstly, okay? So I have a list. If I run this right now, okay, everything is good. I have a list like this. Now I wanted to what? Insert. I said my linked list dot header after Okay, I wanted to add 3 node 6. What does it mean? I wanted to insert a new node 6 after 3. So it should become 4, 1, 2, 3, 6, 5. Let's test it, okay? If it's correct. After insertion, I do the print list. I run this. Okay, I need to have this. Right, you can tell. Insert a new node 6 after 3. You see that? Okay, so it's insert node 6 after 3. Okay, but why I say there's a problem? Okay, let's try this again. If I try said, okay, this is my new list, right? I said insert a node 7 after 10. Okay, so this will become 10. This will become 7. If I run the code, I'm probably gonna get an exception or error. Oh, Aston, what's wrong here?
None of the nodes have the data of 10.
Why? It's telling you in line number 44, right? In line number 44, it has an arrow. Why the arrow can happen? Why?
Because none of the data in the list matches the target data.
Okay, very good. Remember, we are doing the loop, and the condition is checking. Just checking what? Just checking target.data equals to the target node data. And thinking about that, right? If it's not finding anyone, then I keep doing target.equals target.next. Eventually, the target will become none. Right? So looping to the next of the last node, it's become none. So if it's none, but you are still checking none.data, it's not good. That's the reason why I said none-type object has no attribute data. Okay? Has no attribute data. So what is supposed to do? Okay, what is supposed to do? You should do if, right, target. What I'm doing here, I'm checking. Oh, if the target is none. If it's none, I know what? I know I didn't find the target node value. So I should say raise exception. What is the error message I'm putting here? Node with data not found. Okay. Okay. Node with data. Right. I'm using string percentage here. Not found. Right. Okay. Run this. It gives you exception. Node with 10 with data 10 not found. Okay, so that's called a checked exception. It's not a random error, because you know that could be a problem here. And you can return proper messages. That's reason. Okay, I think we're running out of time, but today we mainly cover the 3 different cases of insertion into a list. At first, at last, at after, and also the way how we are testing if your function is running correctly. Okay. I'm gonna ask you to do the same in your assignment. Okay? So, any question? Louis, you good?
Yeah.
Okay. Okay, so I think that's it for today's. Thank you, guys. So enjoy the rest of the week. Have a good night. Bye-bye.
Bye.
Bye.